Hello, everyone. Welcome to episode 249 of the J Situation Podcast. I'm recording this on February 25th, 2025. How are all you wonderful folks doing? Yeah, I hope you're all doing well. Boy, last week's article sure did get some traction. It was neat. Those test reports were super popular. And I don't know what it is. You guys really seem to love them, which is really cool. I'm glad they spread so far and wide like they did. I was looking at the analytics. It was pretty cool. So people are reading those reports all over the world, which is pretty amazing. So thank you to all you folks that spread the word. Thanks to Otter for funding the research study. Huge thanks to all the Pew Science members that help keep the lights on and make it so we can keep doing it. That's the really cool part. So yeah, you're the real MVPs actually. Took a photo of a Knight's Armament SR-25 with this episode for you. It's fitting, considering the Infinity is a 7.62 silencer. So we'll have to see how that shakes out. Little preview of things to come there. So speaking of Pew Science members, though, I heard that the Hush Fest silencer shoot that Jim's Firearms put on in Baton Rouge, I heard that was a big hit. So I was told some people drove all the way from Florida to attend because they heard about it on last week's episode. That's pretty crazy. So I am honored that folks made that trip. I hope it was a blast. I heard good things. Those silencer shoots are really cool. They happen all over the country at different places from time to time. So I'm sure if you Google them, you'll find them. It can be really great to shoot things in person. You know what I mean? Yeah. So today's episode is going to be long. There are a few new people listening to the podcast, so welcome. Some people don't like long things. Some like shorter, small pieces of information given to them quickly. So whatever your preference is, I'm going to give you a little tip. There are timestamps in the episode description. It does not matter if you are listening on Spotify or iTunes or YouTube or directly from the website. Use the timestamps if you like, okay? It will make your life easier if you want to skip around, all right? So you'll get the most out of this, I think, going through all of the topics in order. But as I always say, everyone learns differently, and I am glad to provide you with options, okay? So this is the technical discussion of the Infinity reports. And boy, howdy, is there a lot. So let's go. All right, we're going to get on with the show. If you've been here before, again, welcome back. If you're new to the podcast, welcome. We're glad to have you. I'm glad you have decided to learn about silencers. Okay, timestamps, don't forget them. I'm going to read some ads. You can skip them if you want, or you can find out about the companies who make this podcast possible. Like Legion Athletics, because nothing you do, exercise, sports, really anything is worth doing without consistency. You have to do things all the time if you want to be good at them. And Legion Athletics can help you with that. They have whey protein, pre-workout, post-workout. Do they have everything you need? Of course they don't, but they have a lot of it. Visit legionathletics.com. There's a link in the show notes. Code word PewScience to save 20% off of your first order, which can be a lot of money. And keep using that code even after you order the first time. You'll get 10% off net with points going forward. Get strong. It's important. Legion Athletics. Episode is also brought to you by Silencer Shop. That's right. Largest distributor of silencers in the world. Use their kiosk. Do your fingerprints and photos electronically. Cut down on errors. Simplify your silencer purchasing process. Get a money-back guarantee. No transfer fees. No paperwork errors. Just you and your silencer with no drama. Truly is silencer ownership simplified. Also, did you know about Top Gun Range Houston? If you live in Houston and sometimes you miss those silencer shoots, doesn't matter. You know why? You can go to Top Gun Range, experience their indoor 15-lane shooting range in the largest firearm rental fleet in the entire state of Texas, and rent pistols and rifles and shotguns and machine guns, and you can rent silencers every day that they're open. So you don't have to wait for a silencer shoot. Just go to Top Gun Range. That's right. Check out their rental inventory at topgunrange.com and find them on Instagram at Top Gun Range. Speaking of silencers, did you folks know about Capital Armory? They are here to help meet the demand of this crazy market and also help you with the painful paperwork of silencer purchase and also help you out with a neat little twist. They can ship the silencer directly to you. That's right. If you live in one of the 42 states where silencers are legal, you can order the silencer in your living room and have that silencer delivered to that same living room. It really is that easy. Capital Armory, silencer shipped directly to your door. And finally, and most importantly of all, now and forever, the podcast is brought to you by the Pew Science Laboratory. I'm the technical director of the lab, and I moonlight as a silencer crazy person. In the interest of public education, the lab sponsors this podcast and runs a public research effort, which continues to push the silencer industry forward one test at a time. Visit pewscience.com for the suppression rating. It is the most accurate and simplified hear-and-safe rating for suppressed small arms, based on true human inner ear response of the entire gunshot from before combustion takes place all the way until all the combustion is gone. Pew Science is the home of the silencer sound standard. 7 sections, the most in-depth and accurate silencer data and analysis in the entire known universe, all available to the public 24/7 at pewscience.com. You can support this podcast. You can support all the testing that we talk about every week. You can support the entire lab, keep the lights on, help us, pay the utility bill by joining with a membership at pewscience.com. There's even a donate feature on the review page or podcast page if you don't like recurring stuff. Cancel anytime. Every little bit helps. And if you're not into paying money for stuff, which, hey, I understand. Something that doesn't cost you anything is giving the podcast a listen, a share, rate it good on the Spotify or the iTunes or the YouTubes or wherever you get your information and podcasts. Let folks know that silencers and guns are awesome. Okay, so what we're going to do, one second, I'm going to pause, it's got a cough. Okay, sorry, I'm back. So what we're going to do today, I have 2 topics prepared for you, and it's probably going to be long enough to where I'm going to have to break them into subtopics just because there's a lot to say, okay? So topic 1 is going to be the Sound Signature Review 6178. It's going to be the Otter Creek Labs Infinity on 308 bolt action with 2 different end caps, and then topic 2 is going to be Article 6179, same silencer, but on the Mark 18, this time 3 tests, solid 556, vented 556, and vented 762. Okay. So this silencer has adjustable back pressure. So we're going to go into both of those topics. It will be a long technical discussion with multiple timestamps. So if you get lost or tired or scared, just go ahead and look at the episode description in your favorite podcast provider and skip to where you want to be. Okay. All right. Topic 1, beginning at a time of 7 minutes and 34 seconds. Excellent. Topic 1, Sound Signature Review 6178, the Otter Creek Labs Infinity on 308 bolt action. Okay, this is the new hybrid design silencer from Otter Creek. 2 tests, solid and vented 762 end caps. Okay, this is the technical discussion of the article that was published last week. So you had a week to go check out the test report and read it and digest it and ask questions. Maybe you even printed it out and put it under your pillow and you absorbed some of it through osmosis. Stranger things have happened. Okay, we're in the time of aliens now. They got drones, they got aliens. Who knows, man? You could be like some kind of weird... Anyway, I'm kidding. You've had some time to look at it, hopefully. And if not, that's okay. What we're going to do, we're going to walk through the report step by step. But first, let's talk about the physical characteristics of the Infinity so you really understand what you're getting into with the silencer. Okay, I think this is a good way to do it. And so, to be clear, this silencer is not a lightweight hunting silencer, as I told you last episode. All in, with a direct thread mount, this weighs 20.8 ounces, so basically 21 ounces. Okay, if you are a Pew Science member, I encourage you to go ahead and go to the visualization tool. I hate that I named something and I can't pronounce the word. Where you go to visualize the information in the rankings table in section 7. It's only in the members ranking table. Okay, it's only on the members ranking page. You have to. It's below the table. It's a scatter plot and has filters. So go to that tool, select 308 ammunition, and then move the left side of the weight slider to 20 ounces. Okay, what do you see when you do that? You're going to see the data set shrink to a pretty manageable size, right? What do you have in the group when you do that? Well, you can have both configurations of the Infinity, of course, because we've cut off everything less than 20 ounces with 308. Right? You're going to have the solid and vented end caps of the Infinity, but what else do you have on the chart? Well, you'll have the rugged Surge, the Force Systems Monarch, the Helios QD, the Aero Precision Lahar 30L, the Surefire SOCOM 762 RC2, the Huxworks HXQD 762, the CAT DD, the SOCOM 762 Mini 2. Right? Because those are all silencers that are at least 20 ounces in weight. Right? So the Infinity is clearly in a class with some durable and prolific silencers. Right? With regard to weight. Okay, now some are older, of course, right? You heard me rattle off some old names, and some of them are actually not as durable as the Infinity. Yeah, so for example, the Surefire series, the RC2 series in 762 and 556, or the mini sizes, pick your poison. It's never going to be as durable as an Infinity. And why is that? Is it because of the materials? Yes and no. Yes and no. I mean, the Surefire silencers are indeed Inconel. They are. At least the baffles are. But what about the rest of the silencer? And what about the outer tube? Yeah. And in a Surefire rifle silencer like an RC2, like either 762 or 556, how does it function? Well, just real quick, and again, this is not a talk about Surefire. This is the Infinity talk, but I'm trying to make a point. In an RC2 system, gas is vented relatively quickly to an annular space, yes? You're all familiar with this. That is one of the reasons the total signature reduction technology in the Surefire silencers is classified as a hybrid design in the Pew Science Research Taxonomy. Okay, that's why we classify it like that. The issue here is that where it vents contacts the outer tube, which is, in fact, a tube. And that is where the Surefire silencers will fail with heavy use. They will. The tube will yield. Why? Well, the hot gas impingement on that tube wall is going to weaken it. And the pressure there is a little bit higher, so it's a weak point in the design. Okay, that cannot happen with an Infinity in the same way, and we're going to get into that later. But I just want to point this out really quickly because you have two silencers from two different companies and two different generations of technology. All right, now, even though the RC2 series was ahead of its time, and both the RC2 series and the Infinity uses Inconel, they have drastically different durability metrics objectively. Okay, and I feel it's important for you folks to understand things like this. Okay, let's be objective. Put your feelings, leave them at the door, and come into the feeling-free area because we're just talking about performance. Okay. Also, it's important to note that the Infinity has some clever geometry in the first expansion chamber. I think I said this the other day. At least I thought I did, or maybe I meant to say it. I don't remember if I told you, but the blast chamber or the first expansion chamber of a silencer is a lot like the wing of an aircraft. It's where the magic happens, and it can make or break a design. Yeah, it can. The blast chamber of the Infinity isn't perfect, but it's very good. An excellent design and a detailed design. And sometimes the devil's in the details. There's a wonderful porting in the blast chamber, and it's purposeful. There are geometric features on the first reflector that are also useful. There's also a curvature of the first reflector that's smart. And none of these things would really be as useful without the rest of the silencer. And you don't just mimic a blast chamber of a silencer without purpose and without a plan with what to do with the blast loads after they propagate further. Like, you can't just engineer part of the silencer and hope that it works. It's a holistic system, right? It has to be a holistic design. How many times have I used the word holistic? You know, I once heard a silencer designer from a very large silencer company in the industry make fun of me because I used the word holistic. He mocked me. I said, okay, well, you're the guy designing the silencers. You should heed the advice. Otter Creek did, you know. The Infinity is certainly that. They do manage the blast loads, and they do it differently based upon which end cap is selected. They do. How would they have done that without a holistic design? They didn't just slap some things together and hope it worked. Okay, so, you know, just like the Surefire RC2 series, the Infinity is a hybrid design. Regardless of end cap choice, there's features that allow blast loads to clear off of the first reflector. You're going to clear off the first reflector no matter what, but you get to clear off of it in earlier time than typical if you vent right. Another way to describe that is early time venting. Another way to describe it is a lower accumulation of blast impulse inside the first expansion chamber. Another way to describe that is a low alpha parameter. Okay, this is neglecting later time behavior. It has nothing to do with the end cap, and this is why when you place an infinity on a gun with a solid end cap on the end of the silencer, you're still going to notice a quote-unquote lower back pressure than many conventional designs. You will do that. So how are they doing it? How is Otter Creek doing this? Well, like many things, like the Surefire RC2 series, like the CGS Hyperion family, and there's some other things too, Otter Creek and the Infinity is venting early, and they're utilizing annular cavities in which the blast load can expand independently of primary bore flow. That primary axial bore, you have to decouple propagation from that if you want to be efficient. This allows multiple things to happen. You're getting more expansion volume, which at a basic level helps suppression efficiency, right? But you do so while keeping saturation to a minimum. Okay, and saturation defined, if you want to define it, defining as riding below a total impulse accumulation threshold. So downstream of initial expansion in a silencer, you're going to have varying degrees of secondary and tertiary expansion, along with turbulence generation simultaneously. So during this, if you can stay below that critical pressures and the critical impulses in those zones, you can operate more efficiently. That's just like a general rule. So the critical blast loads for each zone is design dependent, or are design dependent. And that's why silencer design can get complicated. Another name for what I'm describing to you is staged design or pressure staging. Okay, the Infinity is a hybrid design, and it's actually a subclass of silencers called a staged hybrid, if you're curious. Staged hybrids are highly advanced. The most famous example of a staged hybrid is a CGS Hyperion. It's very unique, and to this day, one of the most advanced and high-performance rifle silencers that exists. Actually, pure performance, like an F1 car. It's nasty, dude. If you feed a Hyperion high pressure, it will literally laugh at you. It will. The silencer will laugh at you. If you can fit a projectile through the bore of a Hyperion, chances are it will suppress it in an amazing way. It's a ludicrous silencer, and the technology itself, like the Hyperion technology from the patents, is nuts. Objectively, I don't think there's a silencer designer on Earth that would disagree with that. Even if they outwardly say that, they're lying. If they disagree, I know they're impressed. You have to be, because it's objectively good. And the Infinity is actually not unlike the Hyperion in several ways. Strangely enough, it definitely has some inspiration from it. That's undeniable. In some ways, actually, the Infinity is like a Helios QD. But interestingly enough, the Infinity seems to be more optimized for 5.56 than the Helios QD, whereas the Helios QD seems to be more optimized for 308. It's interesting. Another extremely interesting difference between the Helios QD and the Infinity is the use of early time venting in the Infinity. See, the Helios QD actually does something different than all of the other silencers in the Hyperion family. Instead of having immediate annular expansion past the first orifice, the Helios QD has this big old first reflector, and that actually increases the alpha parameter of the silencer. That's right. So actually, I believe it also increases the omega metric. It's that big a deal. The old school podcast listeners and Pew Science readers will recall you can turn a Helios QD into a Hyperion K or Helios DT by funneling the blast load directly into the first orifice, bypassing the first expansion chamber completely. What does that do? It prohibits reflection and impulse accumulation, dropping alpha and omega directly. That's right. And the reason I'm giving you all of this technical background and also bringing up the CGS technology is because it's not in the article. I didn't really write all that in there, and I think you need to understand it. And it's very important to me that you understand what I'm telling you and why I am telling you what I'm telling you. It is important to me that you understand all of this stuff is real and that physics matter. I would not be, believe me, the sponsors help us do this podcast. They pay us money for reading ads, and that gives incentive to do this for you. Okay. But even with sponsors, I would not spend time every week talking through this with you if I didn't care about it. It would be crazy. You understand? Like, I'm not talking for no reason. Like, I really want you to understand this, and that's why I'm explaining it to you. Okay. Just so we're clear. So I'm going to draw an analogy. The Otter Creek Labs Infinity is similar in concept to an improved Helios QD. Okay, and I say this objectively. If someone had a bunch of time to make a revised Helios QD design, there are things they would do to the blast chamber. Some of those things, in concept, I see in the Infinity. This is just, really just, if you understand silencers, you would agree with me. Another thing the Infinity has in common with staged designs, because it is one, is the baffle geometry variation in accordance with pressure drop later in the stack. This is actually extremely common in silencer design. As expansion changes, some baffle types and shapes tend to work more efficiently. Otter Creek Labs clearly understands this. They implemented that in the Infinity. You can see it. They've posted cutaways publicly. 1 second. I want to go back to something I said earlier with regard to silencers exhibiting varying degrees of secondary and tertiary expansion along with turbulence generation. Maybe I glossed over that. Otter Creek Labs designed this staged hybrid by empirical basis. So what does that mean? That means trial and error. Is that a bad thing? Well, of course it's not a bad thing. It can produce results, clearly. Is it time intensive and expensive? Absolutely. By its nature, that is true, objectively, regardless of what you're talking about. Now, are there other ways to go about it, this process? Of course there are other ways. Engineering has a variety of paths, and some paths can lead you to the same destination, right? Engineering is all about applying science to problem solving. That's what engineering is. I would have called Pew Science something different, but engineering is actually in the name if you say the whole acronym already. So it would be redundant. So we called it Pew Science instead of Pew Engineering. That would be weird. Be professionally engineered weaponeering engineering. Be like, it wouldn't work with the backronym, you know? So I called it Pew Science. But it's really engineering. Okay? Scientists are great. Engineers get things done. So with regard to silencer design, if you don't do it on an empirical basis, like Otter Creek Labs did, you can do it on a semi-empirical basis, and you can supplement your experiments with modeling. Yes? Yes. This is also a very popular engineering approach, and the balance between testing and modeling varies, of course, depending on the testing and the manufacturing and the modeling skills of the engineering team, as you can imagine. Yeah. So at the extreme end, there is a third approach. There is an almost 100% modeling approach where incredibly advanced computational simulations are used, and only after the design is complete does the team decide to do real-time field testing to validate it. You would be surprised how many companies are actually doing that. Some people don't believe it. Just because you have trouble believing something does not mean it's not happening. So, but these are the three basic methods, right? All part of a spectrum, frankly, and each method is rife with pitfalls and potential catastrophe, right? You can imagine on one extreme end, you have Otter Creek Labs did a decent job with the Infinity, but it took them a very long time. Another part of the spectrum, you have Surefire, right? Used both modeling and field testing with the RC3, but certainly fell short in a practical sense. I don't think anyone would argue with that. What part of their process was off? What was it, the modeling or the testing or both? Not sure. I don't work for Surefire. So then on the other extreme end, you have companies like CAT, right? Very modeling intensive, but they also have great testing. So you see, there are multiple ways to go about an engineering approach to silencers, like any system. Yeah? And there are multiple ways to have great success. But there are just as many ways to fail. And I want wanted to give you this kind of this broad practical example case study with some real names, so you could see it's actually real. I wasn't vague, right? I named names, and it's public information, and we have the test data, so we can speak, I think, authoritatively with regard to this subject. Okay, so back to the Infinity strictly now. It's a hybrid design, 3D printed Inconel construction, along with the geometric features of the first expansion chamber and the subsequent vent geometry, the Inconel construction being monolithic 3D printed. It's incredibly strong, very heat resistant, and it is sure to be able to take a lot of abuse. Even though Pew Science has not personally done a burn down test on an Infinity, just by looking at the cutaway of the silencer and knowing the details I have told you, I can tell that it is durable. I would bet you a beer it is very durable. Knowing what we know about silencers, knowing what we know about the Infinity. The rear of the silencer is hub threaded. Yep. So you can use your choice of mount adapter. I know a lot of you like that. I would encourage you, please listen, I would encourage you to pick a mount that does not behave like a cute cherry bomb. That is not a political statement. Please don't turn it into a political statement. It is a statement based upon blast physics. The geometry of a cherry bomb compensator results in undue blast load reflections back down the bore of your rifle. It will reduce the effectiveness of the back pressure reducing design of the Infinity. Okay? So to me, it would be a shame for you to do such a thing. It would be like putting the very cheap tires on your Corvette. You'd be handicapping the system from the jump. It would be irresponsible of you. Please use a direct thread mount or some kind of caged flash hider or something. Keep in mind, pronged flash hiders, like a 3-prong, for example, will jet cut blast baffles, even if the blast baffle's made out of Wolverine's skull, dude. It doesn't matter. Don't kid yourself. Don't pretend. I don't care what it's made out of. Pick a fancy alloy that someone's printing a silencer out of and make believe that a 3-prong won't jet cut it. Make believe. And once you leave your make-believe land and come back to reality with the rest of us, you'll pick a better mount. The other end of the Infinity is threaded for Infinity end caps. I saw someone online asking what the threading was. I don't think that's a good idea. Just use the Otter Creek end caps. Somewhere along the way, and this is another thing, somewhere along the way, people started to think you should be able to have universal thread patterns for everything in the silencer. Hub threading's great. Let's have universal pistons and universal end caps. And enough. Okay? Enough. It's like the Ron Swanson walking through Home Depot and he's like, I know more than you. Trust me, dude. Like, you stop. People want universal thread patterns for everything in a silencer so people can play mad scientist. Look, I'm of the opinion that sometimes you should not do that and don't alter the system. Use the Otter Creek end caps. They do change the behavior, and we're going to get into that topic for 308 here in a little bit. I'm just doing this general thing for you right now. I'm just telling you, just don't try to be a hero on that. It's going to be a waste of your time. On the outside diameter of the silencer, there's a texture pattern. I like how it looks. I like how it feels. I like how functional it is for gripping the silencer to remove it or to install it. It's actually probably subjectively, okay, this is subjective, probably one of my favorite features outside on the outside of the silencer. I think they got that part right. I don't know who came up with it at Otter Creek, but it's awesome. Some silencers are ugly, which is, of course, in the eye of the beholder. Again, subjective. To me, the Infinity is not ugly, which is nice. It's really not. So that's all the physical. Now that I'm already made people mad because I talked about hub and everything, it's fine. Use whatever you want, dude. That's all the physical characteristics and physical design traits of the Infinity I want to tell you. So let's go ahead and do this. Let me do topic 1B at a time of 29 minutes and 31 seconds. Okay, so now let's look at some physics demonstrations. Okay, let's look at the results of the experiments with 762 NATO. So let's go ahead and pull up the first article. Can you do that? It's report 6.178, 6178. at pewscience.com. If you are a member, thank you for your support. You are the real MVPs. You keep the lights on. It's good. You help me feed my family. I like that. They're hungry. No, they are. I got 2 kids. No, we do love your support. Please, if you're a member, pull up the full report. If you are not a member, we still love you. Like, don't get it twisted. And to prove that, you can pull up the free article right now and follow along just fine. You can. Bottom line up front, 28.4 muzzle suppression rating on the 20-inch barrel Savage Model 10 Precision Carbine 308 bolt-action rifle, Federal M80 ball, 7.62 by 51 millimeter NATO ammunition. 1 meter left of the end cap, 1.6 meters above the ground, away from all reflecting surfaces other than the ground, in the true free field, compatible with true mill standard testing. That's right, 28.4 at the muzzle. Okay, yeah. 38.4 suppression rating, 6 inches right of the shooter's right ear. What does that do? That brings us to an overall composite suppression rating with a solid end cap on this host of 39.0. Yeah, 39 flat. Wow. Yeah, so a full category difference between the muzzle and ear and suppression rating. On 308 bolt gun. Actually extremely common. No surprises there, really. Seems to be working exactly as expected. Now, what about the vented end cap? The 7.62 vented end cap. Why did I say 7.62? Well, this is a 308. We're putting 7.62 NATO from it. If you put the 5.56 end cap on it, you're going to have a bad time. Well, yeah, you'll have a bad time. You might have a good time if you're a crazy person. But most reasonable people would have a bad time blowing off their end cap. What about the vented 7.62 end cap on here? Do things change? Do the metrics change? Do the risk metrics for personnel change when you vent more? Yes. You bet your butt things change. But not necessarily how you would think. This is not intuitive. 28.3 muzzle suppression rating, almost the same. Interesting. It went from 28.4 to 28.3. That's interesting. But 28.4 ear suppression rating, way lower. Oh, very interesting. The overall composite rating drops from 39 flat with a solid end cap to 31.8 with vented end cap. Oh, SpaghettiOs. Yeah, what's going on? What's going on here? Yeah, we'll go through the article, but one thing that's really interesting is that it's not only the flow rate that's changing when you change end caps. You're utilizing the silencer differently completely. The pressure field actually changes shape. Unfortunately, or fortunately, depending on your point of view, we have 2 point sources to see that change in these tests, muzzle and ear. So you're seeing a situation in which duration components in the time regime of interest are shifting. And they're shifting such that the shooter gets a completely different blast load dose. Yeah, so we're going to get into that next. Completely different blast load dose. So first, what we'll do, let's scroll down to the first set of data plots in Figure 2. So you're going to scroll down. You're going to see a chart. It's Figure 1. I want you to skip that chart. Yeah, we're going to skip the Otter Creek Labs bar chart in Figure 1 for now. And we're going to come back to it, I promise. Scroll down past that to Figure 2, all the way down to Figure 2. That's Figure 2A and Figure 2B. Here you have the blast overpressure in the free field, 1 meter left of the end cap. Okay? This should be extremely familiar to you because it's showing very typical behavior for this host. It really is. This should be Mickey Mouse actually to you, but it's showing some higher flow rate behavior too. So one thing that's very good is that you're getting a lot of consistency from the Infinity here, and you do have FRP divergence early, but the stability of the internal combustion signature and the coupled jetting, like in early time, it's really strong. It's strong, and I'm very I couldn't be more pleased with the test results here. Very high fidelity, of course, but this shows you the exact signature on the Infinity and how consistent it can be with a solid end cap. So take a look at Figure 2A, the full time scale, pretty standard blowdown duration. You zoom in at early time in Figure 2B, and you can see that consistent early time combustion. When you look at the impulse history, then you scroll down, you can really tell a lot actually. When impulse in Figure 3, the consistency after the first shot's very strong, and you can see a throttle. You actually see a throttle response in early time in figure 3B. You see it takes a while for the impulse to start to ramp. You see that? No, post FRP. You see that throttle takes a little bit of time to ramp. What are you doing? You're delaying propagation, and it's taking a little while to start to build that momentum. Okay, now the FRP is real though. I don't think you should forget about it. Do not sleep on the FRP of the Infinity. You're gonna hear it. Now, when you look at these signatures on 308, when you look at these signatures overall, you would think, hey, that's a mid-size 30 caliber silencer on a bolt gun. Been there, got the t-shirt. Okay. Other than the interesting plateaus from the staging and stuff like that, you might think it's a typical silencer. You really might, if you just looked at this, if you just glanced at it. And you might think, oh, well, that's really consistent after FRP too. That's good. And what the Infinity is not, however, is a high performance 308 bolt gun silencer. Don't get it twisted. It's clear it's not super optimized for this level of combustion volume. It's just not. Things are moving very fast through the Infinity by design, but things aren't moving so fast that particle velocity gets out of control with the solid end cap. So what I need you to do is I need you to read the research notes in the article to understand the difference between this hybrid design and flow-through designs. It's okay. It's important because we don't have time. We have a lot of stuff to talk about today, and I don't have time to read everything to you. So you're going to have to read a little bit. You're going to have to do your homework if you haven't already. Now, members, please look at the shooter's ear waveforms here. Very important. This is going to be very important when you compare the vented end cap performance, because although the suppression rating doesn't change 1 meter left of the end cap that much, when you change end caps on this host, the timing of the increased muzzle blast propagation in the next test, it's gonna mess with what the shooter experiences. So members, please keep figure 5, okay, in your section. Keep figure 5 in mind, so then you can check out subsequently figure 9 in the next section of the report. Understand? And that's what we'll do. We'll move to the vented end cap section now at a time of 36 minutes and 58 seconds. Okay, that's, 1B. Okay, it was 1, maybe this is 1A, and then this is 1B, whatever. This is like this, okay. 1 second. He can't number things. Okay. So the 762 vented, right. So if you keep scrolling down in the article, if you're just joining us, we're talking about the Infinity on the 762 NATO bolt gun. If you now scroll down to section 3 of the article, that's going to be 6.178.3. You're going to see another summary table, okay, and it will say vented end cap in the silencer field. That's table 2, okay, table 2 in the caption of that table. This is the second test of the Infinity. Now, when you look at the free field blast overpressure signatures, again, this time, that would be in figure 6, you're going to see something completely different is happening now. Something completely different. Sure, the amplitudes got higher, and you anticipated that, right? You would. You anticipated that a higher blast overpressure at that location would occur due to the venting. That would make sense to you, yes? But what else changed? Well, the duration changed. And why would that be? Well, you're letting blast loads out faster. Yeah, and how can you tell? Am I just pulling this out of my butt, just talking nonsense? No. How can you tell? Look at the blowdown duration, figure 6A. You can see physically that the blast load is evacuating the silencer faster. Why? Well, because you're venting more at the distal end. How? I'm glad you asked. When you change to the vented end cap of the Infinity, you don't just get more holes. It's not that simple. You do get more holes, but it's important to understand where the holes go or what's going to come through the holes. Okay? Got to understand your holes. The normal Infinity, I almost didn't laugh. I couldn't help. You got to understand your holes. No, don't use that term. The normal Infinity solid end caps, they have a single axial bore hole, right? That means that when you vent blast load, it has to come through the main axial bore. That's straightforward, yes? When you change the end cap to a vented configuration, you're actually adding venting in 2 areas. All right? You're venting additional area from the main bore, as most vented end caps tend to do with silencers, but you're also now venting from the annular space. Remember the Helios QD from CGS? It's like that. It really is. Now, with the Infinity, it's a little more complicated in their annulus, and it's actually changing the pressure stages of the silencer in a different way. So what you're going to do is you're going to dump blast load way faster, as you probably would have guessed, but you're also venting from a region that has bypassed the main bore, and this does several things. Like I told you a second ago, it makes the blowdown duration faster. That's a no-brainer. Another thing it does is it ramps the initial positive phase up with a higher positive phase duration. So you're increasing the amplitude, you're lowering blowdown duration, and you're increasing initial positive phase duration. Okay? That's the key here. If the pressure dump was an inchworm, like if you looked, so in the time domain, if you squint your eyes, turn your head a little bit, and you picture the pressure dump history as an inchworm, and you're scrunching up the inchworm a little more, if that makes sense, when you go to the vented end cap. And where are you scrunching it up? What dimension are you scrunching? Are you shortening? Time, the time domain. You feel me? Okay. The net result of that is what? Faster rise to maximum positive phase impulse. What's another name for that? Steeper initial impulse slope in figure 7. What's another name for that? Lower omegametric. That's right. That's right. Drop in gross back pressure, increase in overall flow rate. Has the alpha state changed in the blast chamber? No. Has the later time flow rate changed the distal end? Yes. Is that directly visible on the raw data plots in the report? Also yes. As open source as you're ever going to get. 5 years running, baby. 5 years running open source. Look at it. Now, what else happens when you vent like this? Like in general, what happens? Well, not only with the Infinity, but in general, what happens? Well, what could happen, potentially, I mean, let me ask you, let me tell you something, brother. No, let me ask you, what could happen? I feel like I wish I had an interactive portion of this podcast. I wish I could like ask questions to you guys like in real time. What could happen if you allowed increased particle velocity to run rampant at the end of a silencer and maybe the flow paths aren't quite as refined as some other high flow designs? What could happen? And then what happens if you saturate everything like this with 308, like with a lot of combustion duration? You could get some erratic behavior, right? You could. And sure enough, we do see that with the Infinity. in this configuration, in shot 5 specifically, it starts to mirror FRP. Oh man, yeah, dude, yeah, this can happen when vent area gets really high. That's just what can happen. This like the physics of it. So, what's the big change here? I'm so sorry. What's the big change here? These are all primary sound field changes adjacent to the muzzle, right? Because we've been talking about the signature 1 meter left of the end cap right now, right? These are all primary sound field changes adjacent to the muzzle. So far, the drop in duration's really, really helping the severity so far. And it's making up for the increase in blast load amplitude. It's almost 1-for-1 helping it. So that's pretty cool. You're not changing your muzzle suppression rating that much. But what happens a little further away back at the shooter's position? Are these faster load application times the same as that slow and steady venting from the solid end cap back behind the muzzle? No. Spatially, it's different. They're much different. So how different is it? Well, members, please look at figure 8 and 9 in the full report. If you look at figure 8 and figure 9 in the full report, you get that. You see that you do have a lower blowdown duration. You do. That's correct. You do. So you do get that benefit that you got at the muzzle, but you were at a much higher suppression rating regime before. So now you get something that is quite unfortunate. You get that fast blast load impact and gives you a double bounce and momentum, and that's the killer here. And members, look at 31 milliseconds approximately at the shooter's ear, and you'll see what I mean. It's not ideal. It's not ideal. Yeah, can't all be roses all the time. You know, not everything we test does well all the time. And it does not matter if it's a client test or an internally funded test. Okay, we treat everything the same. And this is one of those cases. Okay, so you ask yourself, why on earth would you want the vented 762 end cap for 308? Well, the answer, my friends, is for something we haven't tested yet. It's for semi-autos. You wouldn't use the vented 762 end cap on a bolt gun. It would be less than optimal, as this test shows. But if you are running the silencer with a 762 end cap for other purposes, and you didn't want to change the end cap, and you wanted to just put it on your bolt gun in a pinch because you're switching silencers, this is what would happen. So you know you have the data point, okay? It's very good. So let's talk about performance comparisons here. So with a solid end cap, what do we have? Like some chart with all the stuff. This is an article text too, but should I timestamp this? Yeah. Performance comparison. So it's like 1C at a time of 45 minutes and 44 seconds. Yeah, so talking about performance comparisons here, let me put this in my notes so I know what I'm doing here. So this is going to be performance comparison. All right, cool. Yeah. So with the solid end cap, you're punching above several well-known silencers in performance, which is important for you to understand here. And it's not too shabby because this really isn't a bolt gun silencer as far as I'm concerned. So you have to understand kind of where it's fitting, and even though it's not a bolt gun silencer, you're punching above the Silencer Co. Omega, the Harvester, the first gen Nomad, the Sam NS, the Rugged Radiant, the Trash Panda, which is like a big deal, I think. Now, granted, those silencers I just mentioned aren't necessarily the cream of the crop. They're not high performance juggernauts or anything, so don't go around. It's like that meme with the guy on the podium and he's like celebrating with a bottle of champagne, and you zoom out and he's like really like way far down. Like, don't freak out, But those are well-known models that should give you excellent performance peg points, and I think that's important. And I think context is everything. And if there's one thing that 308 bolt gun testing at Pew Science has, is context. The database is nuts. And with the suppression rating, which you can actually use to compare. So that's pretty good. I would say that, again, the Infinity is not a bolt gun can. And so the fact it's hanging with and surpassing the Silencer Co. Omega, even though the Omega is old, is a big deal. Because of what the Infinity can do. Okay, so, speaking of, let's go back to the very top of the report, scroll all the way up to figure 1. I told you we would, right? I didn't forget. In this figure, only Otter Creek Labs rifle silencers are shown on 308 bolt action. You see where the Infinity is sitting, yeah? With a solid end cap, you outperform a Polonium 30 at the muzzle and the ear. You would hope you would. Right? Given the silencer design, because what this shows is even with higher early time flow rate, the solid end cap throttles the momentum enough to do a really good job, all things considered. That's right. So you see how the vented end cap data in the chart starts to equalize the sound field severity due to the duration dropping and the severe jets propagating rearward with that unfortunate timing that members see in their data. Yeah, this is a good this plot. It's a good visual performance comparison illustrating that. Bottom line, really, and you see how a hydrogen L is absolutely walking the Infinity. Why? Why would the hydrogen L be doing that much better? Well, it's a purpose-built gas trap doing gas trap stuff. It's quieter and the back pressure is tremendous. Okay, I hope this all makes sense to you. The Infinity really isn't for bolt guns, in my opinion, but it will work. And this shows you how well it will work. Use the solid end cap for sure. That is definitive, right? Hope that makes sense. I hope that shows you practically why. Okay, now let's say you want to move to a semi-auto platform. Okay, and not only that, you want to take advantage of the fact the silencer is in canal, 3D printed, about the same weight of a 5.56 RC2, and you want to prove or disprove what I just told you about durability. And you want to go full Mark 18 cloner Ranger Danger on this thing. You want to go medieval on the silencer. You want to go all mag dump into trash all day. What would happen? We can talk about that in the next topic. Topic 2, at a time of 49 minutes and 43 seconds. Okay, topic 2, Sound Signature Review 6179. The Infinity on the 556 standard untuned Mark 18. 3 tests. This time, solid 556 end cap, vented 556 end cap, vented 762 end cap, adjustable back pressure. In this technical discussion of the second article published last week, which I am going to do now. I'm going to pull that up on the website. 1 minute, I need a drink of water. 1 second. Oh man, we're almost an hour in. We're making a good time considering how much we have to go through. That's not bad. Okay, so pull up the report, please. The next report 6179 on the website. This one's a doozy. 3 tests, so there's a lot to go through. So let's go on with it. You already know about the silencer. I told you all about that all through topic 1. You already know you can change the end caps. You know exactly how the silencer works. So let's explore exactly how the back pressure changes can manifest when the rubber meets the road. When the gun is a standard tuning, an off-the-shelf Mark 18 from the armory. A typical H2 buffer, an 070 gas port. What happens? So we're going to go solid 556 end cap first, then vented 556 end cap, then vented 762 end cap. Okay? So 556 end cap, buckle up, bottom line up front, 40.0 suppression rating, 1 meter left of the end cap, 1.6 meters above the ground in the true free field, away from all reflecting surfaces other than the ground. 23.4 suppression rating, 6 inches right of the shooter's right ear. That brings us to a composite suppression rating of 40.2 for the Infinity with its solid end cap on the standard untuned Mark 18. And remember, what does that mean, standard untuned? It means the standard mil-spec Mark 18 configuration of an 070 gas port, standard buffer spring, H2 buffer. I even tell you in the each data plot where the stock is positioned. And you can see the exact same type of stock, so you can duplicate this test. It's easy. It's not easy, it's doable for you. Remember, we surveyed armorers in law enforcement and military to ask how the rifles were configured. That is the configuration that's tested. So, with a standard Mark 18, not with a smaller gas port or heavier buffer than an H2, you're getting 23.4 shooter's ear suppression rating with the Infinity with a solid end cap. Keep that in the back of your mind. Okay, 40 at the muzzle, 23.4 at the ear. Now, change to the 556 vented end cap. Okay, what happens? Muzzle suppression rating dropped to 32, so you drop quite a bit. What happens to the shooter's ear suppression rating? Goes up to 26.6, from 23.4 to 26.6. So again, this untuned gun. Interesting, right? Okay, untuned gun. Now, change to the 762 vented end cap. Even more axial bore vent area. So you're vented from the annulus and you're venting even more from the primary bore. What happens? Muzzle suppression rating drops further, 25.4. You went from 40 to 32 to 25.4. Makes sense, right? Venting more and more blast load. Makes sense. It's getting more severe. Shooter's ear suppression rating drops a little bit also to 25.4. So you went from 23.4, you went up to 26.6. Now you went back down 25.4. Oh, you lowered your back pressure by a lot. But now your muzzle blast got so severe it started to impact the shooter. Oh, shoot. Wow. Yeah. So what's the sweet spot for the standard untuned Mark 18 for the shooter? Maybe the 556 vented end cap. But what's the sweet spot for someone tuning their rifle? Like what if you shrunk your gas port? Would you still want the vented end cap over the solid end cap? Maybe. Or maybe not. Yeah, so we're going to get into this so we can help you answer that question. But now that you've seen the overall results, please scroll down a little bit, and I want you to stop it at figure 1 here. Okay, so unlike in the 308 bolt gun talk today, we're going to look at this first section of this review first. One moment. Man, talking all day. So we're going to look at the first section first. Jeez Louise. 1 second. Okay, I'm back. Sorry about that. I got a frog in my throat. I'm gonna try. We're gonna get this talk done now. In the bar chart in Figure 1, you have several silencers to look at. Okay, I think there's 1, 2, 3, 4, 5, 6. Okay, there's 7. You have 7 overall scenarios for the standard untuned Mark 18. You have the unsuppressed case. You have the Infinity with the 3 tested end caps I just described to you: solid 556, vented 556, vented 762. And you also have the Polonium K, the Polonium 30, and the full-size Polonium. Okay, this is a very good chart for illustrating the bottom line of how the Polonium series works and how the Infinity works in all the configurations. Okay, so we're going to start at the bottom. Let's start at the bottom, shall we? Polonium. You all should know how it performs. 37.6 at the muzzle, but 19.7 at the ear. Why such a low shooter's ear suppression rating for the Polonium on this standard SBR? Well, because the Polonium has high back pressure. And not just high back pressure overall, not just a high omega metric and a low late time flow rate. No, not just that. The Polonium also has low early time flow rate. There is absolutely no venting off of the first reflector, absolutely no blast chamber venting other than through the main bore. It has conventional cones. Is it efficient for suppression? Absolutely. But it's a gas trap. And it's a gas trap that will send blast load reflections back into your barrel. So go to the next silencer up on the chart. Infinity with solid end cap. What do you see immediately? Well, it's quieter at the muzzle than the Polonium for sure. That's a good thing. But what else? Suppression rating at the shooter's ear is higher too. Why? How can that be? It's with the solid 556 end cap. It's not even a vented end cap. How is it beating the Polonium? Well, it is with the solid 556 end cap, but the early time venting in the Infinity blast chamber into the annular channels of the Infinity is already paying dividends. There's less blast load impulse accumulation in the first expansion chamber. The load is clearing off of the first reflector more quickly. This lowers the propensity for the ejection port blast to increase. So that, along with the less severe muzzle blast, buys you a few points of risk reduction at the shooter's ear. Pretty cool, right? Yeah, so the Infinity's already outperforming the Polonium, and you haven't even seen what else it can do yet. Okay, so hold that thought. I'm going to go to the next silencer, Polonium 30. It's always performed better than the standard Polonium at the shooter's ear on an untuned gun, right? Why? Why would that be? Well, bigger bore. So that's a primitive back pressure reduction, right? What did that do? It resulted in less impulse accumulation in the blast chamber, even with reflections. The main bore is big enough to also act as a pseudo extra vent area. There's a lot of silencer companies who use that method to drop back pressure. It's easy and cheap and inefficient. Because what do you sacrifice? Well, you sacrifice muzzle suppression. Easy to see in the chart, right? Polonium 30 is an inefficient 5.56 silencer overall. It has lower back pressure than a Polonium, but in a primitive way, and it still has blast load reflections. Not good, not ideal. Now move to the next silencer. What's the next silencer? Infinity again, but this time vented 5.56 end cap. Okay, louder than the solid 5.56 end cap Infinity, but look at the metrics. Quieter than the Polonium 30 at the muzzle, and quieter or less hazardous than all of the silencers at the shooter's ear on the chart. Hence the sweet spot I was talking about, right? For the operator. Huge deal. Very, very balanced. This is the configuration to put on an untuned 5.56 gun all day, every day, right? Louder at the muzzle, but you had to sacrifice that with the Infinity. Now, next silencer up. Let's go back again to the previous generation design. Here is a Polonium K, just like a Polonium, but shorter. A few less baffles. Same muzzle suppression rating as the Infinity with a 5.56 vented end cap. So right now, the vented 5.56 Infinity is looking even better. Now, what's the shooter's ear suppression rating of the Polonium K on the host, though? 20? Basically like the full-size Polonium? That's pretty hazardous. Why? You reduce back pressure by removing some baffles from the full-size polonium to get to the polonium K. You did, but not nearly enough. And again, that's a primitive way to do it. And you're still getting blast reflections off that blast baffle, not venting in the blast chamber. What's the most efficient and high-performance way to reduce meaningful back pressure in a silencer? Venting the blast chamber and clearing wave reflections off of the blast baffle more expediently. You already know that. I've said it to you 12 times today. So now you see the Infinity spanking the Polonium series hard, and all the Poloniums. But we still have one more silencer configuration left in the chart. The Infinity with the vented 762 end cap. Same vented end cap that was evaluated in the 308 bolt action study, but this time the silencer's on a 556 SBR. Suppression ratings at both the muzzle and the ear in this configuration are 25.4 flat, 25.4 at the muzzle, 25.4 at the ear. Why? I told you why earlier. Back pressure dropped a lot, but the muzzle blast increased too much, and now you're just not as efficient as the vented 556 end cap is. All make sense? Good. It should. It's in black and white. So look at the chart again. Listen to what I said if you need to repeat it. That's the good thing about the podcast. Just hit repeat, dude. And read it again. Nothing's going anywhere. We don't delete anything. Okay? 1 second. If you didn't get it the first time, you can get it the second time. If you didn't get it the second time, you can get it the third time. There's no limit. I tell you what, when I was when I was coming up and learning engineering, when I was in grad school, there's times I sat in my bedroom reading a chapter of a book 12 times to try to get it right until I was happy. You should have no shame in trying to learn something. Okay? It's important. If you try your best and you still fail, well, that's fine. You tried. If you don't try and you give up and you fail, well, that's your fault. That's how I look at it. So what I'm going to do, I'm going to illustrate some of this to you in a little bit different way now. Look at the chart again. Okay, look at the chart again. I'm going to tell you something that's not shown on the chart directly. Every system in that chart is placed on the chart in order of its omega metric. So, lowest omega at the top, that's the unsuppressed case, as you could imagine. Highest omega at the bottom, that's the standard full-size polonium. Yes? Okay. If omega, or the late time flow rate, was the only thing that mattered for back pressure, this chart would look a little different, wouldn't it? For example, here's a point. For example, the Polonium K has a lower omega than the Infinity with a vented 556 end cap. Right? How do you know that? Well, I'm telling you because it's in the chart. It's in the order. However, look at the difference in shooter's ear suppression rating. Same muzzle rating, drastically different ear rating. That's because omega is not alone in the physics discussion here. It's always with alpha, unless alpha is identical across the silencers, which makes it a constant, which makes it drop out of the equation. Okay? You can use omega alone to rank back pressure of silencers if and only if their alpha states are similar. What does that mean? That means if it's a rugged rifle silencer or poloniums with similar bore sizes like a K and a full size, or Sandman LSK, or Trash Panda and Thunder Chicken, stuff like that. Blast chambers are all the same. Doesn't matter. But if you change alpha by changing the blast chamber, you're screwed. Now you have to consider more than just omega in the back pressure determination, so that the limit of that simplified parameter, the utility drops. You understand? There's another thing you can do. You can just test on a semiauto and see what happens. Up to you. There's a lot of ways to figure this out. And this stuff is real. Just so you understand, this chart shows you it's real, and you can get all these silencer configurations and run them on your rifles and test this for yourself if you like. And another thing you can do if you're a Q silencer person, for example, you can go get a full Nelson and a Thunder Chicken, or a half Nelson and a Trash Panda, and count the baffles. You'll see the Nelson silencers have at least one more baffle than the Thunder Chicken and the Trash Panda, right? And the Thunder Chicken and the Trash Panda run a cherry bomb. Yes? Which silencers do you think have higher back pressure? The Nelson series or the Thunder Chicken and the Trash Panda? It's the Thunder Chicken and the Trash Panda, not the full Nelsons. Or not the full Nelson and half Nelson. Why? Even though the Nelsons have more baffles, they have lower back pressure than the Thunder Chicken and the Trash Panda. Why? Because of the cherry bomb, which drives alpha through the roof due to shock reflections. Just because you think you can flow gas through an orifice doesn't mean there's no blast load impulse accumulation from lack of clearing. You guys that think blast loads move like water through a garden hose are missing compressible flow and shock physics. That's why the cherry bomb increases back pressure, and it's not because it's taking up volume in the blast chamber. That's not how this works. Okay? It's not blast chamber volume that influences back pressure. It's shock reflections and impulse accumulation. Volume can be tied to that, but not in this case. Correlation doesn't imply causation. And we verified this on a scar. You can too. Okay? So the amount of data and analysis in figure 1, this bar chart, it's literally insane, right? It really is when you really think about the gravity of what's in figure 1 here. It's all for one manufacturer too. If I was Otter Creek Labs, I would print this out and put it on the refrigerator, or at least print it out and put it in a book and put it in a time capsule. Don't lose it. Don't lose it. It's your whole rifle silencer pedigree for 5.56, right here in Figure 1. The amount of power. Do you understand the amount of power in that chart? What that shows you? It's crazy. It's useful, and it's actionable, and it's correct. Now, the $1 million question for you, for a lot of you, is, what if I tune my gun? Yeah, great question. Glad you asked. If you tune your gun, you get to be a mad scientist, and it can actually be, you can be responsible too. You might even be safer. The Infinity is advanced enough such that if you decide to tune your gun, let's say by using an adjustable gas block, you can probably reach into the 30 zone at the shooter's ear on the Mark 18 with a 5.56 solid end cap. Probably. So in that case, maybe the most efficient configuration for you would be with that end cap, with the 5.56 solid end cap. But hold on a second though, because not so fast. Because what if, for example, what if you want to shoot full auto, right, or fast semi-auto, mag dump in the trash? Remember I told you what to do? Is the early time flow rate in the Infinity high enough to prevent significant gas stack? I mean, we know the polonium, even on a tuned gun, is still going to gas you to kingdom come if you fire quickly. That much you know. I know it, you know it. People who try to pretend it's not real know it. But the Infinity? I mean, you have to try it. I have a feeling that you're going to be pleasantly surprised. Worst case, for your tuned gun, you use the vented 5.56 end cap. But if you're tuning, try tuning it with a solid 5.56 end cap first. Could be smart. Because keep in mind the physics of this. When I say gas stack, you understand what I'm saying. It's when you're injecting high pressure gas into an already superheated volume, and you can't expand as quickly. And that can be exacerbated when you're not clearing blast impulse out of the chamber fast enough. And so the Infinity, because it has a lower alpha than the Polonium series, it's not sending those shock reflections back into the bore. It's not stagnating. It's not ramping up the impulse history inside the first expansion chamber. You're venting off that first reflector of the Infinity. Your gas stack simply will not be as severe, even with a solid end cap. This is the alpha state, not the omega state. Okay? So is this new information I'm telling you? No. And frankly, what about the risk matrix? Did I pull the 30 zone shooter's ear metric out of my butt? No. You have precedent for this. Where? Well, report 6.110 and 6.111. Maximum defense DSX on the surge upper with a Mark 18 as well. That's a case study. Mark 18, 2 different gas port sizes, nothing else changed with a high back pressure silencer. Read it, learn it, remember it, print it out, put it under your pillow. If you tune a Mark 18, that's what can happen with a high back pressure silencer. Is it going to avoid gas stack with all your high back pressure silencers? No. Is slow fire semi-auto going to subject you to the risk metrics in the suppression rating chart as shown in the maximum defense surge article? Probably, yeah. Okay, so you can also get you can also get an even more advanced silencer that can hit the 30 zone at the ear without tuning. You can do that too, but the Infinity's not that. No. Is the Infinity advanced? Yeah, it is, especially for Otter Creek, but it's not a PTR or a CAT silencer. Don't get it twisted. The Infinity does very well. Don't get me wrong, but there are levels to this. You guys do realize like multiple things can be good, and sometimes not everything's going to be the best, and that's okay. You don't have to freak out. Okay, I really want you to understand that this is real. You got to remove your emotions from this and your weird brand loyalties. Okay, because it's troublesome for your physical understanding of the known world, or your understanding of the physical world, or whatever I'm trying to lecture you on. Whatever insult I'm trying to hurl at you right now. No, the Infinity does very well. Don't get me wrong, but there are levels to this, right? Like ideally, you wouldn't have to mess with an end cap, right? So, Infinity is extremely versatile. It's vertical. I hope it's not vertical. You don't want to shoot it straight up. It's extremely versatile. Might be one of the most versatile rifle silencers that exists. I think. I think it might be one of the most versatile rifle silencers that exists, as long as you know what to do with it, right? As long as you know how to use it, which I hope we're helping you with here. I think you're going to have a good time with it. Now, we've come a long way. I haven't even gone through the detailed test results like we always do of this report. So, look, I gave you the bottom line. I think I've explained everything about the silencer, how it works. I'd be remiss if I didn't hit some nitty gritty, though. We got to. We're already, my last timestamp was at 50 minutes, around 50 minutes. We're already at 110. Yeah, let me hit some nitty gritty in each of the three tests quickly, just for completeness, just so we can make sure we can go back and look at the stuff, just if you need proof, right? Let's do that. Let's do, okay, so 5.56 solid. B at a time of 1 hour, 11 minutes, and 15 seconds. Good enough for government work. Solid 5.56 end cap. Yeah, scroll down to section 6.179.2. You'll have all the data here for you. Cliff's notes. FRP is better on this gun than it is on 308. That's good. It's still there, but better. Solid 5.56 end cap results in longer blowdown, as you can expect. Check out figure 2, right? Blast overpressure in the free field. You know what's up. Again, just like I explained for 308, this is a hybrid design. Research note 2 here is actually really important. It's a hybrid design, but the Infinity cannot do what the PTR PIP does or the cat surge bypass does. It just can't. It needs more downstream venting, which is what the end cap changes are for. That's right. You saw that in the chart in figure 1, and you will see that in the ranking section. Okay, there are levels to the game. Like I was saying, a lot of hybrids are listed in this article. Okay, is that research note 2? Yeah, that's research note. No, it's research note. They're listed in research note 3, so go check that out. Members, when you look at the shooter's ear data for the 5.56 solid end cap test, you're going to see features that begin to show you low back pressure behavior already, and it's a solid end cap, which is awesome, right? And that should be a clear sign to you that if you do decide to tune your gun, you might just keep this end cap on the silencer and only run it like this. So go try that, okay? You can see that in the data. You can see it's a teaser, like for members, figure 5. You're looking at that. It's actually giving you front-loaded FRP. You're like, oh my God, it's giving me front-loaded FRP, and it's a solid 5.56 end cap. That's a good sign. It's a great sign. Okay, so go try it. Okay, now let's do the vented 5.56 end cap. Let me write this down. Vented at a time of 1 hour, 13 minutes, and 10 seconds. Okay, yeah. So vented 5.56 end cap. So this is section 6.179.3. Vented from the annulus now, right? What happens? I already told you. Higher blast pressure, shorter duration. Figure 6A, figure 6B shows you the blast loads. Excellent. You can see how the momentum propagation changes. Now, here's something to watch with the Infinity. This is something to keep in mind. Look at the impulse waveforms in figure 7. Look at shot 2, the blue curve. Okay, see what happens? Runs away. Why? Vent area is getting big. Uncontrolled combustion propagation. Only happened in 1 out of the 6 shots. Not terrible, but it's there. Watch that. Is that a short barrel thing? I mean, probably, but it shows that the design's, it's advanced, but not as advanced as some others. Again, levels. Still good performance, but what did you have to do? You had to drastically increase vent area. You had to change the end cap, and this is what can happen when you do that. There are compromises. Now, on the flip side, members, again, check out the shooter's ear data in the full report in your article. Now you really see that front-loaded impulse, don't you? You really see it. Now you're getting more confidence, aren't you? Getting more confidence. Probably don't have to tune your gun. And if you do, things might get even more pleasant for you. But shot 2 is still lurking there in the background, isn't it? That muzzle blast, you can't hide. You are the shooter. You are holding the gun. It is expanding spherically in three-dimensional space like blast loads tend to do. It can happen, and it's in your data as well, isn't it? So optimal configuration for an untuned gun, vented 5.56 end cap probably might even be optimal for a tuned gun. If you're mag dumping, this configuration is strong, but not as high pure suppression performance as the solid end cap, right? As we've discussed. Okay, so let's do next. It's going to be A, B, C, D. This is going to be the 7.62 vented at a time of 1 hour, 15 minutes, and 26 seconds. Okay, so lightning round. 7.62 vented. Here's what on the Mark 18. Here's what you really need to do, where you really need to not count your chickens before they're hatched, so to speak. Notice anything? Oh, scroll down to this test. It's going to be in section 6.179.4 of the report. Notice anything? I don't know, completely bonkers in Figure 11. Keep in mind, as you know, Figure 10 is showing you the blast overpressure in the free field, super short blowdown duration, ground reflection clearly visible. Things are venting fast, the amplitude is sky high, but that is not all. The bonker stuff is in Figure 11, and that's showing you how things are getting out of control in a hurry. Okay, here, you're venting so much from the Infinity that the combustion is running wild. Can't increase the vent area that much without this weapon system, freaking out a little bit. It's you're gonna have consistency problems with this particular design with the Infinity. If you have to choose between the vented 5.56 end cap and the vented 7.62 end cap on this host weapon, clearly you are going to pick the vented 5.56 because unless of course you're quickly swapping silencers between hosts, you need the vented 7.62 configuration for some other reason on another gun. So now at least you have data for this. So you know you'll be getting into. And this goes to the thing I told you last week. I disagreed with Otter Creek Labs. I think they said this configuration was preferred for 5.56 based on back pressure. I disagree based on the analysis of the test results, personally. Look at the shooter's ear waveforms. Please, if you're a member, scroll down more. It's section 6.179.4.2. Signatures at the shooter's ear. It's non-trivial, guys. Yeah, you have super short duration, but you have erratic combustion propagation here. It's actually kind of nuts. So just be careful with that. Like that's not going to be great for you. So I think that's all I have on the Infinity for you. In the supersonic ammunition combustion regime for now. So, I mean, we're going to go over subsonic 300 blackout when we publish that, which we will, and just not right now. We have other things we can do right now, but it will come. That's going to round out the performance envelope for this for now, at least until we can do it on the SR25 that you see in the picture with today's episode. That's going to be awesome. And maybe we do it on an AK or 2. That's going to be awesome too. Stay tuned. But overall, though, when you scroll down here to whatchamacallit, figure number 14, and here, dude, this article is nuts. Figure 14, that bar chart shows a lot. Use the ranking section because it's color coded now and like super fast because these bar charts are getting nuts. So so what you need to know: the Infinity is a variable performance hybrid silencer. Make it quiet, tune your gun. Make it louder, don't tune as much. That's the name of the game. This is bringing Otter Creek Labs into the realm of competition with PTR and CAT and Liberty Precision Machine when it comes to using hybrid designs for high performance to try to accomplish what Huxworks does and still reduce particle velocity to not have uncontrolled reflections and boomy signatures. That's a drawback of the Huxworks stuff. This is kind of trying to refine that like the other folks are doing, okay? And to be clear, when stuff in the article is written like this will achieve significantly higher performance than legacy designs, like a Trash Panda and a Dominus and an Arx and a Sam NS and a Razor 762, that's not written to throw shade. That's written to make people understand this is real. This is for all the marbles. And performance is factual, quantitative, and there's written record of it. 179 reports long, 200 analytical data records in the rankings, and we're not stopping. Okay? I hope you enjoyed this. I hope you got a lot out of it. Pew Science forever. All right? Stay safe. I'll talk with you folks again soon. Bye.